Welcome children to another video session. Previous classes we had learnt about some properties of chords of a circle. Now today we will be using those properties to solve a few sums. Come to exercise 10.4, take up question number 2. Now what is given in the question, children? Two equal chords of a circle. Now suppose we have this circle with center O, AB, CD are two equal chords of the circle intersecting at point P. Okay, this is given, and what you have to prove that the segments of the chords are equal. What are the segments? Now AB is made up of two parts, AP and PB. Similarly, this CD is DP and PC. You have to prove AP is equal to DP and CP is equal to BP. Okay, so this is what you have to prove and what is given. Now whenever you have to prove, children, first you need to write given. So we start with given. Now you need to write full. I am just telling what is given here. So you can write in given a circle with center O. AB and CD are two equal chords intersecting at point P. This much is given. Next we have to prove. What you have to prove? The segments are equal. That is, you have to prove AP is equal to DP and PC is equal to PB. This we have to prove. For this we do a small construction. What is the construction? We draw two perpendiculars from O on the chords. OL and OM are two perpendiculars from O on the chord, and we also join OP. Okay, this is over. Now we start proof. Proof. We consider in triangle OLP and triangle OMP. What do we have? Anything equal in this two triangles? First one is OP is common. What else? OL equal to OM. Now is OL equal to OM? Yes, think of it. Is OL equal to OM? Yes. Why? Because we have already learnt equal chords are equidistant from the center. Since AB and CD are equal chords of the circle, they are at equal distances from the center, and therefore we have OL equal to OM. So you need to write the full equal chords are equidistant from the center. Now we need one more point. We got 2 points. What is the third point? Yes, both these angles are 90 degrees. So we can write angle OLP is equal to angle OMP equal to 90 degree. Why? By construction. So therefore triangle OLP is congruent to triangle OMP. Which rule? We have one angle and this one side and this one side. This is RHS. Congruency rule. Okay, now if the two triangles are congruent, we can write the corresponding sides parts are equal. So we have LP equal to MP. CP, CT. LP equal to MP. Okay, up to this understood, children? Next, what we do is, okay, I rub it. Now, we have AB. AB is equal to CD. This is given to us. Now, AB, can we write for AB, AL equal to LB? Can we write this? AL equal to LB? Yes. Why? Again, we have studied, children, the perpendicular from the center to a chord bisects the chord, isn't it? So L is the midpoint of AB, so we can write AL equal to LB equal to. Similarly, for CD, we can write M is the midpoint, DM equal to CM. Okay, since AB equal to CD and L and M are their midpoints, all of them are equal. Okay, now let's come to AP. Now AP is equal to AL plus LP. AL plus LP. Now for AL we can write DM, they are equal, and for LP we can write MP from here, isn't it? AL is equal to DM. For AL we have written DM, and for LP we get MP. Now what is DM plus MP? DM plus MP, we have DP. This is equal to DP, and children, we had to prove this AP equal to DP. So one part of the question is proved. Second part, this is one segment, and what is the other part? The other segment is also equal. Again, since we have AB equal to CD, this is given. Now AB is, or you can write AB minus AP equal to CD minus, for AP can we write DP? We have proved AP is equal to DP, so we are subtracting the same thing, AP and DP. They are equal, AP equal to DP. Now what is AB minus AP? From this AB you are subtracting AP. What's left? BP. CD minus DP. This is CD minus DP. So what's left? This part, BC. Okay. So this is the second part of the segment that you had to prove. So understood, children? So this is how we use the properties of chords to prove certain things. This is clear? Okay. Let's come to another sum. Okay, children, let's see another sum. Question number 4. Now what is given in the question? A line intersects two concentric circles. Now what are concentric circles? Circles with the same center and different radii are concentric circles. Here you can see two circles having the center O. Their radii are different. So these circles are concentric circles. So a line intersecting two concentric circles at A, B, C and D. You have to prove, what you have to prove? AB equal to CD. For this we do a small construction. What is the construction? We drop a perpendicular. Suppose L. We draw OL perpendicular to AD. Okay, now see the proof. Now just see here, O is the center of the circle and AD is the chord of the bigger circle. Listen children, O is the center of, take the big circle, O is the center of the circle, AD is a chord of the circle, and perpendicular from the center to a chord bisects the chord. This property is known to you. Okay, so what can we write? AL is equal to LD. Why? Just now I said perpendicular from the center to a chord bisects the chord. Now you need to write the full, children. Perpendicular from the center to a chord bisects the chord. So let this be equation number 1. Now we consider the smaller circle. There O is the center of the smaller circle and BC is a chord of the smaller circle. So again we have this OL is perpendicular to BC. So we can write BL is equal to LC. The same reason, perpendicular from the center to a chord, BC is chord of the smaller circle. Now let this be equation number 2 from 1 and 2. We can subtract the two equations. So what you have, AL minus BL will be equal to LD minus LC. Or what is AL minus BL? This full is AL. From this you are subtracting BL. So what's left? AB. Similarly, LD minus LC. This is LD. You're subtracting this part. So what's left? CD. So AB equal to CD. So proved, children. So understood. This is what we had to prove. So okay. The next topic, children, is cyclic quadrilateral. Now what is cyclic quadrilateral? Now you can see here a circle, center, and quadrilateral. You know what is a quadrilateral? Any figure bounded by 4 sides is a quadrilateral. Here A, B, C, D is a quadrilateral. Now if it so happens that all the vertices of the quadrilateral fall on the circle, this quadrilateral is called cyclic quadrilateral. So what is a cyclic quadrilateral? If all the 4 vertices of a quadrilateral lie on the circle, the quadrilateral is cyclic quadrilateral. Now the cyclic quadrilateral has a special property. What is it? The sum of opposite angles of a cyclic quadrilateral is 180. That is, angle A plus angle C is equal to 180 degree. Similarly, angle B plus angle D is also 180 degree. Okay, children. The converse is also true. That is, if you have a quadrilateral where the sum of opposite angles is 180, if you have a quadrilateral where sum of opposite angles is 180, then we say the quadrilateral is cyclic. So both ways it is true. Okay, children. Okay, now let's use this to solve few sums from your exercise. Okay, children, now let's move on to exercise 10.5, question number 1. Now what is given in the question? A circle, center O, A, B, C are 3 points on the circle such that this angle AOB is 60, angle BOC is 30, D is any point on the remaining part of the circle, and you need to find this angle, angle ADC. You need to find angle ADC. Now, the previous day we had learnt a theorem which said that an arc of a circle, it arc subtends double the angle at the center than on any part on the remaining part of the circle. You remember the theorem, children? Okay, that means angle, so we have the proof, angle ADC will be half of angle AOC. You know the reason why? Now we need to find this half of, what is angle AOC? Angle AOC is angle AOB plus angle BOC, that is half of, angle AOB is given 60 degree plus 30 degree, that is half of 90 degree, that is 45 degree. So we have angle ADC is 45 degree. Understood? Okay, let's see another sum. Okay, children, another sum. See question number 3. What is given? PQR are 3 points on the circle with center O. The figure is not that accurate. The center is not at the center actually, but I made it bigger just for you to get it clear. Now, and this angle is given, PQR is given as 100. You need to find this angle, angle OPR, that is X. We need to find this angle. Now, how do we find it? Now, children, if just see here, this arc PR is making angle PQR on the circle. So, this angle must be how much? This angle must be just the double, because you have learned the theorem, an arc subtends double the angle at the center than what it subtends on the remaining part of the circle. So if this is 100, this angle must be just the double, 200. Okay, so PQR 100 degree. So therefore this angle POR is equal to just double. You know the reason why? You need to write the reason, the statement of the theorem. Now, if this angle is 200, what about this part? Now you know, children, this full angle around a point is 360 degree. This is known to you. So if this portion is 200, what about this portion, this angle? So you can write in triangle POR, angle POR will be how much? 360 minus 200, that is 160 degree. So you get this angle as 160 degree. Again see, in this triangle POR, we have 3 angles, so we can write X plus 160 degree plus angle PRO (180 degree), because you know the sum of 3 angles of a triangle is 180 degree. Okay, now what is this angle PRO? Now if you see it, OP is the radius of the circle, OR is also the radius of the circle, that is OP is equal to OR, and you know very well in a triangle angles opposite to equal sides are equal. So since OP is equal to OR, these two angles must be equal. So instead of this we can write X (180). So just simplify it. X plus X, 2X is equal to all degrees. So 180 minus 160 is 20 degree. So x will be, that is 10. So you get this angle x, angle OPR is equal to 10 degrees. Understood, children? Another sum. Okay, next children, we have sum number 8 from exercise 10.5. What is given there? A trapezium ABCD in which the non-parallel sides are equal. Which are the non-parallel sides? This AD and BC are the non-parallel sides of the trapezium and they are equal. What you have to show is ABCD is cyclic. Now, to show ABCD is cyclic, what we need to show? Sum of opposite angles is 180 degree. So let's start there. First you need to write given. What is given? ABCD is a trapezium in which non-parallel sides AD and BC are equal. And what you have to prove? To prove ABCD is cyclic. For that we do a small construction. We have some construction. What is the construction? We are drawing two perpendiculars. This DL and CM are two perpendiculars from C and D on AB. So construction is, we draw DL perpendicular, or you can write, we can draw DL and CM perpendiculars on AB. Proof. We consider these two triangles. So in triangle ADL and triangle this one BCM, in these two triangles, what all we have equal? AD equal to BC. Why? Given. What else we have? Can we write this? DL equal to CM. DL equal to CM. Are they equal? Yes. Yes, they are equal. Why? Because since this is a trapezium, DC and AB are parallel, and you know distance between parallel sides remains same, equal. So we can write DL is equal to CM. You can write the reason, because ABCD is a trapezium. And what else we have? We have angle DLA is equal to angle CMB 90 degree by construction. So therefore we can write the two triangles are congruent. Triangle DAL congruent to triangle CBM. Which rule? This is 90 degree, this is the hypotenuse, one side. So we have RHS congruency rule. Now if the two triangles are congruent, their parts are equal, so we can write this angle is equal to this angle. We can write, yes. So therefore we have angle DAL equal to angle CBM. CPCT, corresponding parts of congruent triangles. Now we have up to this. Now see here, again consider this. DC is parallel to AB and DA is the transversal. So can we write this? Angle CDA plus angle DAL equal to 180. Angle CDA plus DAL. This two, the sum is 180. Can we write it? Yes. Think, what is the reason why is the sum 180? Because you know, children, interior angles on the same side of the transversal are supplementary. This is known to you? Okay. So these are interior angles and transversal same side are supplementary. Interior angles on the same side of the transversal are supplementary. Isn't it? So okay, now again just see here. Now this angle CDA or angle CDA plus DAL. We have already proved this angle DAL is equal to CBM. So here instead of DAL, can we write this angle CBM? Yes. If this is equation 1, we have the reason from equation 1. Now what is CDA? This angle. This is angle CDA. What is CBM? CBM. This angle. Sum of these two angles is 180, and we have already said before, if the sum of opposite sides of a sum of opposite angles of a quadrilateral is 180, the quadrilateral is cyclic. Now this D and B are opposite angles of the quadrilateral, and we have shown them the sum is 180. So therefore we can write, therefore ABCD is a cyclic quadrilateral. Okay children, understood? So proved. So this is how we prove by taking the help of the properties of chords or the theorems that we have learnt. So okay, so let it be this much. Thank you children.